Now, I did a square, and we looked at a circle earlier, but I could, I could play with that a little bit and change it around a little bit. So instead of having it just do a circle, it's going to draw a circle, and that maybe this is, oh, sorry, turtle dot circle. Yeah, like that. And we could also say that we want to do another circle, and that could be maybe -5 times I, and so we could get like a figure 8 going on here, so that could be kind of cool. There's lots of different things that you could play with on this. And he should slowly start to rotate. Yeah, you can see he's slowly changing his angle a little bit. Not a lot, but it'll get there little by little. And of course, we can up the speed a bit, so let's put it on 0, so it's considered instantaneous. There we go, so that's pretty cool. And it'll go for 100 of those, 100 circle pairs. What we could also do if we wanted to is we could get it to change colors, right? So if we do turtle.color, we could actually have in here where like this eye, this same eye is changing the color. So yeah. Now the issue is we showed hex code and we showed like putting a color inside of quotes, but we can also use RGB values. So RGB, and we could set actual variables for this, but I just want to use I. Now there's going to be a little bit of a problem with this, so I'll go ahead and run it and show you what happens. And it freaks out. So it's actually expecting like a percentage here, and so if we don't want to try to convert this to a percentage, and I don't want to, we can tell it that we want turtle.color mode to be set to 255, and so instead of using percentages, it's going to use the 0 to 255 scale. As it approaches 0, it's becoming black. As it approaches 255, it's approaching like 100% saturation or brightness of that particular value. So 255 would be 100% brightness on the red, on the green, or on the blue as appropriate. Now this is going to go up to 100, so it's never going to reach that. So maybe instead I want this to be like times 2. It still won't get all the way up there. It's only going to get up to 200, but it will be at least approaching it, and you should be able to get sort of the idea. So let's go ahead and run this. And you can see it's getting lighter. It's definitely becoming a lighter gray. Now it's never going to reach white because it never hit 255. Now you might say, if I'm changing R, G, and B, red, green, and blue, why are we not seeing those colors? And that's because the value for all three is staying the same, which puts it at a grayscale value between black to white. If we want this to actually change into a particular shade, then we need to adjust these so they are not all the same. So maybe this one is just I, and maybe this one is by 2, and maybe this one is by 5. Now we're going to run into a little problem here because this will eventually hit over 255, and it's going to complain. But even doing that, even until it complains, you'll still see it start to shift into the blue color spectrum, and any moment now it'll freak out. So yeah, it hit 260, and so it got angry and it closed. Now of course we could also maybe modify this. So maybe we say that it's times B here. We can create a new variable, and we can say that B equals I. And now that will still cause a problem once it hits above 255 here, but we could also say that if B becomes greater than 255, then we just want B to equal 255. So that way it will never go above 255, and that allows us to get much higher. We could actually take this up to like 127 if we wanted to, and it should be okay as long as green doesn't break 255. There you go. So it becomes, oh, what happens? Oh, it's still it's still got above because it does the math here. My mistake. So 255 divided by 5 is 51. So that actually means that blue cannot be above 51. So if blue is above 51, then blue needs to become 51. Now it should cooperate. Let's give it a shot. There we go. I think we're good. So it'll hit full blue, and it should start approaching cyan as that green is being added into that blue. There we go. Nice. Ta-da! So there's some cool things you can play with. Now there is one more thing that I want to discuss in this video. Before we had made a square instead of the circle, and apparently I can't go back that far. That's cool. Let's see. So if I go to local history, I can say show history, and I can look for that file from earlier. This should be good. Do we have square? Yeah, here's my square, so we can see the differences. This is a pretty cool way to compare versions as well. So I want this. Revert. There we go. And we've got my square again. So instead of a square, what I could also do is I could actually define maybe just like shape, if I can spell, and we could do size, and we could do sides, and we can actually decide how many sides we want it to be. So this would be sides. Oh. Alright, and then I have it calling square, so let's change this to shape. And we now need another variable in here, so we'll just also call this sides, and now set sides somewhere else. If we run this now, like let's say that sides is going to equal 5, we're going to run into a little bit of a problem. So, I mean, it looks coolish, I guess. I mean, it's kind of a neat thing that's going on here. But I still am drawing squares. I don't have a pentagon, or if I switch it to 6, I won't have a hexagon. So how do I make this actually match, so that way the angle is proper for it to make that? So if you remember back to geometry, the angle of a polygon, assuming that all the sides are equal and all the angles are equal, is 360 divided by the number of sides. So if I stick that in, let's see if it works. There we go. So now I've got pentagons instead of squares. And I could change this to be hexagons. Which takes a little bit longer because it's a couple more lines that the little guy has to draw. But you get the idea. So I could dynamically change the number of sides by doing that. Now, of course, I could even have it change the number of sides as well based on I. So this could actually be I instead, and let's see if it is happy with that. There we go. So it's going to slowly approach a circle as the sides get larger and larger. That's sure starting to take a while. Problematically, it gets a little bit hard to see because it's getting so big. Let's maybe try like toning down the size a bit. Maybe we're only going to multiply it by 2. Maybe we just change this to just I, and we'll run that. And there we go. That's a little bit more reasonable. You can start to see that it is very quickly approaching a circle as those sides drastically increase in number. It's still a little bumpy looking, but that is becoming quite circle-like. Of course, I could have just told him to draw a circle if I wanted my turtle to draw a circle. But you know, you get the concept, you get the idea. Of course, this takes a lot longer too because I have it set to 0 and it takes that long, whereas if I had it actually drawing a real circle set on 0, it would be done instantaneously. But you know, it's still cool. How it runs each time is going to differ based on just random chance. Because if we look at the program itself, these values here are determining how far forward it's going to go, or if it takes a step back, and these ones are going to determine the wobble as it's moving. So is it going to wobble a little bit over to the right, a little bit over to the left, or keep going straight? Now, of course, I could cheat, right? Like, So like if I want orange to win, which one is orange? Orange is Ted. If I want Ted to win, you know, I can be like, that's cool. Like I'm going to automatically give Ted a little boost. Like Ted is always going to be 2 points higher than whatever his random chance is. And you know, maybe I want to make sure that Ted doesn't wobble as much as the others. So I'm gonna say that it's like TA divided by 2. You know, and maybe you're like, hey, like Sue is my turtle. Sue's gonna win. And I can be like, that's cool. I'm gonna cheat a little bit, and your turtle's gonna have a tough time. So, and maybe I want to like multiply this by like 0.15 or something, just to give your turtle like an extra chance to screw up. So now I can like run it, and you've got Sue and I've got Ted, and I've stacked the cards in my favor, and you're not aware. And now my turtle's probably gonna win, and yours is probably gonna lose, right? So Ted's doing pretty well. Look at Sue. Sue is just having trouble. I don't know. You chose a bad turtle, but Ted's doing all right. I mean, yellow's beating me, but you know, yellow and red just went right out of bounds, so I'm still good. Ted, what are you doing? Oh, look at that. Wouldn't that be how it goes? Like, even with cheating, I still lost. But anyway, you get the idea, right? So I could stack the cards in my favor. We could try this again. So, you know, I might not win every single time because, you know, there's still some randomized elements in there, but if I play consistently, I should beat you if I'm choosing Ted and you're choosing Sue, if I've not exactly played fair. Look at that. You're already out. Sue, you're a mess. And look at that. Ted wins. Ted win. Yeah, Ted won. Ted won. That was close. Red almost beat me anyway. But you get the idea, right? So we could make it look like it's still random, but actually, you know, increase it in our odds by manipulating the variables a little bit, not exactly being fair. So, which, you know, I'm not saying is something you should do, because that's dishonest and immoral, but, you know, you should be aware that it could be done, because, you know, you might be interacting with something, or, you know, playing a game or something, or of interactive program, where, you know, maybe it's supposed to be fair, and there might be something a little imbalanced or screwy in there, which could be accidental. You know, if you have different characters you can choose with different characteristics and different traits and different skills, you know, maybe it's just not well balanced, because, you know, if everything is different, it might be hard to make sure it's fair. But if everything is supposed to be fair and everything's identical, then, you know, there could be something else going on too that could give someone a slight advantage. So yeah, fun with turtles.